and outer diameters of a cable are 3 centimeters and 8.5 centimeters. Okay, now let us take this is a core of a cable. He has given two dielectric materials which is having permittivities of 5 and 3 respectively. Okay, let us take this is a cable. This having a radius r. Okay, now this one is r1, whereas this one is capital R. Okay, he has given permittivities of 5 and 3. Inner radius R is equal to 1.5 centimeters. In question he has given diameter, so convert to radian. Capital R outer diameter is 4.25 centimeters. Okay, now we know that this is capacitor grading type. Epsilon 1 R into G1 is equal to epsilon 2 R1 into G2. Okay, so 5 into 1.5 into maximum working stress he has given us 38 for one. Another one is 28. So this is 28. So R1 is equal to 3.39 centimeters. Now what is the thickness of cable 1? R1 minus R. Okay, now R1 we found it as 3.39 minus 1.5. We will get it as around 1.89 centimeters. Thickness of cable 2 is capital R minus R1, which is equal to 4.25 minus 3.39, which is equal to 0.35 centimeters. Now V is equal to E max by root 2 into R ln R1 by R. Okay, plus E max by root 2 into R1 ln R by R1. Okay, when you substitute these values, you will get it as 48.03 kilovolts. We need RMS values. Okay. Option is C. Given the whole data here, three-phase alternator feeds power to a constant UPF load. Okay, here we are having 100 megawatt load, which is unity power factor. What does it mean that reactive power is equal to 0 through a three-phase transmission line. Line to line voltage at the terminals of the machine is maintained constant at 11 kilovolts. The per unit positive sequence impedance of line based on 100 MVA 11 kilovolts is 0.2. Okay. Now, the line-to-line voltage at the terminals is measured to be less than 11 kilovolts. If this is less than 11 kilovolts, the total reactive power to be injected at the terminals to increase the line-to-line voltage at the load terminals to 11 kilovolts. Now, suddenly what happened at the load terminals, if it is less than 11 kilovolts, that means we have to inject reactive power Q to maintain voltage as earlier 11 kilovolts. So what is the injected reactive power he is asking. Okay, X per unit is equal to, we know that X actual into MVA base by kV base whole square. Okay, so I can find this from this. X actual is equal to 0.2 into 11 square by 100, which is equal to 0.242 ohms. Okay, from this I can find QR is equal to Vs into VR by X into cos delta minus 1.0 by X VR square into sine 90 degrees. Okay, and PR is equal to Vs VR by X into sine delta minus 1.0 by X into VR square into cos 90, which is 0. Okay, from this I can write PR is equal to Vs VR by X into sine delta. Okay, since theta is equal to 90 degrees here cos 90 is 0. Okay, now he has given it as 100 megawatt. Okay, voltage value is 11, so 11 square 0.242 into sine delta. From this our found delta as 11.5 degrees. Now QR is equal to Vs into VR. So this is 11 square by 0.242 ohms into cos delta is cos 11.5 minus V square 0.242 into, now the voltage is not 11 kilovolts. Okay, we have to inject this time amount of reactive power. From this, we found it as QR is equal to minus 10.1 MVAR. Okay, now what is the demand here? QR plus QC. This is compensation one we have. So I can write this as QR reactive power to the line, QC as compensating machine we have at the load side is equal to 0. From this I can find QC as 10.1 MVAR. Okay, plus 10.1 MVAR. So option A is the correct answer. 50 Hz 440 volts induction motor developing full load torque at 4 Hz slip frequency. Calculate the slip frequency if the motor is supplied from 40 Hz 400 volts, 440 volts supply developing full load torque. We have to calculate slip frequency if the same motor is supplied from 40 Hz. Earlier is supplied from 50 Hz, so I supplied from 40 Hz, same voltage rating as 440 volts at developing full load torque. Okay, we know that torque is directly proportional to S by F. Okay, I can write from this S1 by F1 is equal to S2 by F2. Okay, S1 is equal to, he has given 4 Hz, so it is around, you will get it as 0.08. Okay, SF is equal to 4, so S is equal to 4 by 50, this is 0.08. So 0.08 by F1 is 50, which is equal to S2 by 40. From this I can calculate S2 as 0.068. Now what is S2 into F? 0.068 into 40. So this is 2.56 Hz. So option D is the correct answer. 40 kilowatt 4-pole 50 Hz induction motor having 90% efficiency. So power output is equal to 40 kilowatt. Efficiency is given as 90%. Okay, this is 0.9 is equal to, I can write this is output by output plus losses into 100. If it is 90, since he has given, we have represented as 0.9, no need to mention the 100. Okay. Now losses is equal to 4.44 kilowatt. Okay. Now loss equal to 4.44 kilowatt. From this, if you found it, okay. Substitute here. Here we have to substitute 40 kilowatt. So this is also 40 kilowatt. You will get losses as 4.44 kilowatt. He has given copper losses by 2. That is, half of the copper losses is equal to mechanical loss plus core loss. Okay, which is equal to core loss. Now I represent copper loss is equal to A. Now what is total loss here? Total losses is equal to, since we have to neglect stator copper loss, A plus A by 2 plus A by 2. So this is equal to 2 times of A, which is equal to 4.44 kilowatt. So A is equal to 2.22 kilowatt. So mechanical loss is equal to 1.11 kilowatt, which is equal to core loss. Okay. Now A gap of PG is equal to 40 plus 2.22 plus 1.11, which is 43.33 kilowatt. Now PG is equal to copper losses by S. From this I can find S is equal to 2.2 by 43.33. This is 0.051. 2 is the answer. So option A is the correct one.